Hello everybody, my name is Sudev Kurur, and in this video, let's look at deploying an Azure NetApp Files stack using Terraform and Ansible. What is Ansible? Ansible is an open source software from the Red Hat family. It supports configuration management and application deployment. Ansible also supports multiple integrations such as Microsoft Azure, AWS, Google Cloud, NetApp, etc. It uses a declarative language to describe system configuration. In this demo, let's deploy and configure multiple infrastructure components on Microsoft Azure. Firstly, we deploy a virtual network. Then, we will deploy two subnets, an ANF delegated subnet and an ANF client subnet. We will then create an ANF capacity pool and volume with an appropriate export policy. On the ANF client subnet, we will deploy a virtual machine with a secure network security group. In order to configure and mount the ANF volume, we will use Ansible. Consider a scenario wherein we have a cluster of virtual machines, and say we need to configure the cluster of virtual machines as web servers. We could log into each server and configure them manually. This is time consuming and we would require a lot of manual labor. This is where we could use a tool like Ansible to automate the configuration management. The series of tasks are defined in an Ansible playbook, and these playbooks can be used to manage configuration and deployments to remote machines. For this demo, I will be configuring the ANF client virtual machine with the following tasks. First, create a new directory for my ANF mount point. Then install the NFS utilities and mount the volume. In addition, I will also set up the client machine as a web server, hence will install and configure the appropriate packages. Finally, I will be downloading and deploying my PHP files. Before we jump into the demo, there are a couple of prerequisites. We need to have a Microsoft Azure account, we need to ensure our NetApp account is whitelisted, and we need to install and configure Terraform as well as Ansible. For this demo, I have already created all the Terraform and Ansible files. The VNet resources are defined in the vnet.terraform file. All the ANF resources are defined in the anf.terraform file. Similarly, we have the network interfaces.terraform and the vm.tf file. I have also created my Ansible playbook in order to configure my client machine as a web server. In the vm.terraform file, we have defined a local provisioner. In this section, we configure and deploy the Ansible playbook on the client machine. Now, since we have all the Terraform and Ansible playbooks defined, let's look at deploying this ANF stack. Another quick note, in order to mount the ANF volume, we need to ensure that our ANF resources are created before our virtual machine is created. In order to achieve this, we can use the depends on condition in Terraform. Let's quickly run the Terraform commands. From the Terraform plan command, we can see that it's going to create 9 new resources. Now let's run the Terraform apply command. The virtual machine has been deployed, and now Terraform has triggered the Ansible playbook command using the local provisioner. We can see that the tasks defined in our playbook are being executed. For example, we can see that the task create a new directory for the ANF NFS mount point being executed. Similarly, the install NFS utilities, mounting the ANF NFS volume, etc. Finally, we can see that the deployment has completed. We can also see the public IP address of the virtual machine from the Terraform output section. Let's verify if Terraform and Ansible worked as per plan. I have copied the IP address, and let me try accessing my sample web page. Yep, so our website has been successfully deployed. We can see the existing mounts on the server. We can see that there is the ANF mounted successfully. Let's quickly verify this on the Azure console. So if we look at the volume and if we look at the mount path, we can confirm that the IP address and the mount path is the same. In this demo, we managed to successfully deploy and configure infrastructure on Azure without logging into the console. Also, our entire infrastructure was defined as code. Ideally, we would want engineers to work in a collaborated manner. For this, they could utilize a source control repository like GitHub. Multiple repositories are created based on the appropriate stack. They would then clone the repository to their local machine and deploy them using Terraform and Ansible. This is one of the ways we can define and deploy our complete infrastructure as code. To wrap up this video, let's look at the benefits of IAC. There are three main benefits. 1. The cost. Reduction in cost by using automations. 2. The speed or agility. We could create or destroy infrastructure using a single Terraform command. 3. The risk. Removes errors and identifies security issues by using proper version control.